is the behavioral biometrics and then the processing algorithms. So just like we said, the physical biometrics is concerned about your physical characteristics, things that we can find on you, fingerprints, iris, and so on. But the behavioral biometrics refers to the things that identify individuals based on patterns in their behavior rather than what body characteristics. So these behavioral patterns are developed naturally over time. So these are habits, emotions that we develop over time. Just like if someone is born in Accra or in a Gan community, that person learns how to speak Gan. If the person is born in the Akan community, the person knows how to speak the Chi. If the person is born in an Ewe community, the person learns how to speak the Ewe. With behavioral biometrics, what we are saying is it is more concerned and influenced by some of these patterns. So they are influenced by habits, emotions, environment, health condition, education, and lifestyle. Health condition, education, and lifestyle. So we all have a way that we live our life. Your lifestyle can be termed as or can influence your behavioral biometric. So unlike the physiological biometrics such as fingerprints or iris, behavioral biometrics are dynamic and may change gradually over time. So this is where I want you to pay attention to. Behavioral biometrics are dynamic and may change over time. Remember we said the physiological biometrics, they are usually stable throughout the person's lifespan. But we are saying with the behavioral biometrics, they are capable of changing gradually over time because it is influenced by habits, emotions, environment, health conditions, education, and lifestyle. And once environment alone can even influence your behavioral biometric, what it means is it is going to change over time. Where we are living, we have different climate conditions. We are now enjoying the rainy season. As time goes by, we will get to enjoy the harmattan, then we come back again to the rainy season. During the rainy season, our behavioral pattern changes. During the harmattan, our behavioral pattern also changes. So just like how we are saying it here, the physiological biometrics usually is stable over time, but with behavioral biometrics, it changes gradually over time, and it is affected by several conditions. The health condition, for instance, you may be walking normal within the next 1 hour, then after 2 hours time you are now limping because you fell down, you have a cut on your knee, you broke a finger or so. Then your pattern of behaving changes. So behavioral biometrics are not stable over time, but they may change gradually over time. So behavioral biometric systems are widely used in continuous authentication, fraud detection, cybersecurity, online examination, surveillance, and intelligent monitoring systems. So we are saying with behavioral biometrics, we use it for continuous authentication. I have explained this the last time when we met. We are saying continuous authentication simply means we are continuously trying to find out who is who. So if you log into maybe your banking system, instead of your banking system always asking you that enter your password to continue every 5 minutes, we can use behavioral biometric to authenticate the person. How you move the screen around, how you hover on items, how you type, and all those things can be used to authenticate you. So behavioral biometrics are usually used in continuous authentication. 2, fraud detection. Now, those of you who have actually read a little bit into the banking fraud, the credit card fraud, and those things, we realize that most of the machine learning technologies or machine learning models to determine whether a transaction is fraud usually learns the behavioral pattern. Is the person trying to purchase items continuously within a certain period? Is that the normal behavior of the person? All these are used in search models to determine what fraud. And those are what we call behavioral biometrics. Then we have cyber security. Now, in cyber security, one of the most weakest link when it comes to a system is not actually the technology behind it, but the human behind the machine. It is the human that is the weakest link, because if you can convince a human to share their password, to click on a link, or to do any other thing, that person becomes what? A cyber security risk. So at the end of the day, we use behavioral patterns when it comes to cyber security to protect systems. Specifically, if you know that every time the person logs in, the person takes about 2 or 3 minutes or 2 or 3 seconds to perform an activity. The moment a bot logs in, the bot is always going to be faster than the human, and the bot is not going to be so careful when highlighting on text. The bot is going to highlight on so many texts at a single time, and the human cannot do that. So we can use it in cyber security. Please, the bot that I am saying is the bot, not the purchasing one. And then we have online examination. So God willing, next week we are going to do our mid-semester examination, and we are going to do it online, and we are going to use the course that we are learning to do our mid-sem online. So there is a portal that you will log in, and the portal will monitor your behavior, your gestures and everything when you are writing the exam. So we are going to have a feel of the behavioral biometrics with our mid-sem portal that we are going to use. It's a very nice portal which we are all going to experience it to learn the behavioral biometrics. So after writing the exam, we will have a discussion on behavioral biometrics again for about 15 minutes on how the system has been implemented in the online examination portal. So I will leave that one here for now. Then we have surveillance. Like I told you earlier on last week, when you go to the prisons and the rest, they use, I don't know of Ghana, but when you go outside the country, they use behavioral biometrics to monitor prisoners. Based on the pattern that someone is moving, you can actually determine that this person wants to do something to another person, or something is going wrong somewhere. So they use behavioral biometrics a lot in prisons to surveil criminals, to make sure that they don't cause commotion any point in time. When they detect that this particular person, the way you have been moving around all this while, you have been calm, and all of a sudden you are moving up and down, or your pattern of movement has changed, then the system will tag you for them to keep an eye on you. When they realize you may cause commotion or cause someone a harm, they just bring you out and keep you somewhere else away from the general population. Then we have intelligent monitoring systems. So we will also observe this in the online examination that we are going to do, which is the mid-sem. It's going to be a nice experience. Don't worry, we will all experience it together. So what are the characteristics of behavioral biometrics? 1, difficult to imitate accurately. Now, when we were kids, there were times that you are coming to the house and you are trying to behave like your dad or your mom, trying to speak in their tone or their voice. You are trying to copy them. Have we all tried that before? Hello? Have you tried that before? Trying to imitate a parent?
Oh, sir.
Hello?
Yes, sir.
You have tried it before, eh?
Yes, sir.
Okay. Now, have you seen how difficult is it? Sometimes you are trying to let people. Sometimes you want to send a sibling, and you intentionally try to use your mom or your dad's tone of speaking or voice, so that the person will think, oh, I am mama nesumami and I am dada nesumami, then the person will go. and it is very difficult. It is not easy to imitate. Even how someone walks, it is not that simple to imitate how the person what moves. So behavioral biometrics are very difficult to what imitate. And then we have dynamic. Behavioral biometrics, just like I was saying earlier on, it is not stable. It gradually changes. So it is very dynamic. You may learn how someone speaks today. In 2-3 days time, because of health complications or something, or change in environment, the person will be speaking in a different tone of voice. So it is dynamic, it changes. Someone is able to write well today or type well today. 3 days time, oh, that person has gotten into an accident, his or her palm is feeling hurt. So the pace at which the person types has now slowed down. So it is kind of what? Dynamic. And the third point is, it is what? Measurable. Now, in the beginning of the course, we said bio means what? Life. And metrics means what? Please, who remembers?
Statistics.
Thank you. So whatever characteristics or whatever biometric type that we are using, it should be what? Measurable. So it automatically tells us that behavioral biometrics is what? Measurable. And then the last one is useful for continuous monitoring. So this one, we are all going to experience it with the online examination platform that we will use for our midterm, so that you will get to experience it. It is useful for continuous monitoring. So when you are writing the exam, the system is useful for such activity. You are always being observed, and if any pattern falls outside the domain, you will get to know. Now, these are useful how do you call it, characteristics of behavioral biometrics. But however, they may be affected by one, stress. So when you are stressed, you have a way of behaving. You don't act like your normal self. Sometimes you are sitting there and you tell yourself, and then the moment you say that, you know that you are feeling stressed, you want to relax. Sometimes someone will meet you and the person will look at you and the person will say, and then so it may be affected by what? Stress. The question is, how did the person determine that you are stressed? Sometimes when you go to the office, you are always active. Then all of a sudden one morning you came and you are behaving slow. Someone can tell that, then the person knows that there is something wrong with you. So all these are what? Patterns, and it can be affected by stress. It can be affected by fatigue, just like I was saying. You are tired. You are just tired. You need some rest. And when you are tired, it affects your behavioral pattern. How you talk, how you move. Sometimes, even when you are using your phone, you yourself, you can tell. Me ampa anka me fa phone here. Me be TikTok anka me hwɛ saa na me scroll pa nso ene. Me ampa me be a video baako koraa me timi hwɛ no twice. So it can be affected by what? Fatigue. And then injuries. We can all relate to this. One way or the other, you had a cut on your knee, your toe, or somewhere on your leg. One way or the other, along the line when you were growing up. You can even just hit your knee to a door or to something. And the moment that happens, you realize that your way of walking has what? Automatically changed. And then we have environmental changes. We can all testify when it started raining. How we behave has actually changed. When we want to wake up in the morning, it has now become an issue. Because sometimes during the dawn, then it is raining. Your behavioral pattern has changed. You wake up in the morning, one panka, and so because of saying you now started at 20, sorry, and I say, heater na inye dwuma na gas asan na chese wa ohun ne oye ohun. So all these what changes affect our pattern. Then you become slow, your movement becomes restricted. Sometimes you want to go out, but because of the environmental changes, you are wondering, hey, eti mi mpie ana, eti mami mpie, mi pie kura, uti afoma obebre. All these affect your patterns. And the last one is emotional rate. We can all relate. When you are happy, it's like you become hyperactive. When you are sad, you become really slow. You don't really want to do anything. You just want to sit somewhere, relax, and just think about yourself. So emotional state also affects what? Behavioral biometrics. Please, is there any question so far? Okay. So we have the major types of behavioral biometrics. The first one is voice recognition. The second one is speech recognition. The third one is handwriting recognition. The fourth one is signature verification. We have the fifth one, which is typing pattern recognition. The sixth one, which is gait recognition. We have a seventh one, which is lip movement recognition. We have mouse movement recognition. We have touchscreen behavior recognition. There are more to this, but I just wanted to give you a glimpse of how everything looks like. So all these things are what we call behavioral biometric. So what is the voice recognition all about? Voice recognition identifies individuals using unique vocal characteristics. So the human voice is influenced by, we have what we call the vocal cord structure. Some of us who did the integrated science to a point, we had to draw that. So that vocal cord, we have drawn it before. So that is what we call the vocal cord structure. We have the throat shape, we have the nasal cavity, we have the mouth structure, we have speaking rhythm, and we have pitch, and the last one is pronunciation style. So it's a combination of this that we use to what? Detect voice recognition. So let's proceed. Voice recognition combines physiological voice characteristics and then behavioral speaking what? Patterns. Then we have the types of voice recognition. We have text-dependent voice recognition. So when you speak a particular fixed phrase for the system to detect your voice, that is what we call text-dependent voice recognition. Please pay attention to this part. When you have a phrase that you need to speak that phrase for the system to detect your voice, that is what we call text-dependent voice recognition. Because if you say anything outside that phrase, the system will find difficulty to detect your voice. But if you are able to speak out that phrase, that is what we call the text-dependent voice recognition. So usually in the movies, you get to see this. There are some popular movies, when you get to the door, you are supposed to sing a particular song. When you are able to sing the song well, the system will be able to determine whether it is you or it is not you. That is what we call the text-dependent voice recognition. So your voice has already been recorded in that song. So you need to speak the exact text in the song for the system to determine that it is you. Now the advantages is that it has a higher accuracy and easier matching process. It has a higher accuracy and easier matching process. So it's easy to match the entire voice because of the phrase that you have, the fixed phrase that you have already been given. The disadvantage is that it has limited flexibility. So without that phrase, you cannot bypass the system. So limited flexibility. And then the second one is text independent voice recognition. So you can speak naturally without predefined words or phrases. Now this is the part where maybe it's a door that you need to get into a building. When you get there this time around, you don't need to say any particular phrase. You can just say anything and the system will analyze your voice and isolate the unique point. So you need your vocal cord and the rest, so the system will detect your pitch and the rest, and then the system will decide whether it is you or not you. We don't have any predefined text for you. Whatever it is that you will say, the system has now the capacity to analyze what you have said and determine your voice out of it. So that is what we call the text independent voice recognition. The advantage is that it is more flexible and useful for surveillance. More flexible and useful for surveillance. But the disadvantage is that it is usually computationally complex. Remember, whatever that you are going to say, the system now has the burden to analyze everything fully and then fish out your voice. So it is what? Computationally complex. Okay. So what is the voice recognition process? We have already gone through this process. So let's just go through this one, then we can proceed. So the microphone captures the speaker's voice. That is the voice signal. So just like the thumbprint, when you put your thumb on the device captures what? Your thumb. So this one, it captures what? Your voice. So the voice signal is captured, and then the signal is goes for what? Pre-processing. So this one too I explained in class. Pre-processing. You have something that you want to move or cancel out the noise. Like I was using one of you as an example. You take a picture, you want to beautify that picture. You give it to AI, AI beautifies the picture for you, takes out all the pimples and the rest from your face. That is what we call pre-processing. You are canceling out all the noise and you are picking exactly what you need from it. And then it goes for feature extraction. Remember, just like the thumbprint, when you put a thumb on the device, we don't need the entire thumb. We need the unique what? Points on the thumb to what? Recognize you. So the same thing applies to the voice. We need a pitch, we need a frequency, we need a tone, we need the MFCC coefficient, we need the spectral what? Information. These are the things that we need. We don't need your entire voice recording. No, we don't need everything. We need these particular items to be able to identify you uniquely. So once we are done with pre-processing, we extract these features from it, and once we have the features, we move on to the template creation. So the extracted voice features are now converted to what? Templates, and then the next stage is what? The matching. I hope we all still remember this process, just like how we went through the physiological biometrics. Please, do we remember? Hello.
Yes, sir.
Okay.
Yes, sir.
So the application of voice recognition, telephone banking, smart assistant, remote authentication, call center security, mobile applications, and so more. The unfortunate thing is, for our country, I have not seen the banks doing telephone banking using voice recognition. Usually, they ask you about your date of birth, your Ghana card number, and some personal information to authenticate who is trying to make inquiries on the account. But in the advanced countries, when you open an account, your voice is actually authenticated on the account. So when you are trying to do anything and you are speaking, they can authenticate you through your voice on the phone. So advantages of voice recognition: contactless authentication. Unlike the fingerprint, you need to touch. This one, you don't need to touch anything. Convenient for remote verification. Just like I was saying, phone call, your bank can authenticate you through your voice. Then the third one is low hardware cost. This one doesn't really require hardware. You can use your phone for voice recognition once the mobile device has a microphone. I have actually written a code for a testing of this. So when we are done with the class, I'll forward the code to you. You can scan through, then I'll give you a small assignment on that. You work on it for me. Limitations of voice recognition. Background noise affects performance, just like the thumbprint. When you have too much dirt on your thumb, what it means is the system cannot what? Pick the fingerprint. So the same thing applies to the voice. When you have so much noise at the background, the system cannot isolate your voice. Illness changes what? Voice quality. When you lose your voice, when your voice becomes faint, it affects what? Your voice quality, and it will prevent you from authenticating. Then vulnerable to replay attacks. So replay attack, someone recording your voice and replaying it to the system. So this only works when you are doing the predefined phrase. But if it's not a predefined phrase, doing the replay attacks becomes a little bit difficult. After the mid-semester exam, when we meet, we are going to discuss what we call what's the name of this? Liveness detection. We are going to discuss what we call liveness detection. So we will discuss how you can prevent some of these things. The next one is speech recognition. Speech recognition converts spoken language into machine readable text. Unlike voice recognition, speech recognition focuses on what is being said rather than who is speaking. Remember, voice recognition is trying to what? Identify you. Speech recognition is converting what you are speaking into what? Machine readable text. That is the only difference between the two. Voice identify you. Speech convert it to what? Machine what? Readable text. Application of speech recognition, virtual assistants, voice control systems, automated customer service, and smart devices. So something like Siri, something like the how do you call it, the Gemini AI and the rest. When you are speaking into them, what they are actually doing is speech what? Recognition, not voice recognition. You have a question and you are asking, hey Gemini, what is this and that. What you are doing is what we call speech recognition. You are not doing voice recognition. So please take note of the key differences. Now we have common speech recognition algorithms. We have the hidden Markov models. We have the deep neural networks. We have the recurrent neural networks, and we have the long short-term memory networks. We usually call them the LSTM. So the last time I was asking if you have done machine learning, you would have discussed these things at machine learning. That's why I was asking. Then the next thing is handwriting recognition. Handwriting recognition. So handwriting recognition identifies individuals based on their handwriting styles and writing behavior. Every person develops a unique writing speed, pressure, stroke styles, slant, spacing, and what? Rhythm. I don't know if this has happened to you before. When you were in SHS, someone will leave their note behind and there is no name behind the notebook. But the moment you see the handwriting, you can tell that this is the person who wrote this note. So I know that person. Can we all relate to that?
Yes, sir.
Exactly. That is what we call handwriting recognition. Your handwriting style leaves a pattern. How you space, how they put pressure on your pen, the speed that you take to write, the slantness and the spacing. That is what we use for handwriting recognition. We have offline handwriting recognition, which analyzes scanned handwriting images. And we have online handwriting recognition, which captures dynamic writing behavior during writing. So pen pressure, speed, stroke order, timing, they are all part. Then we have applications of handwriting recognition. We have it for signature verification, banking system, document authentication, and forensic analysis. The one that we can all relate to is the signature verification when you go to the banks. Sometimes when you are trying to withdraw cash, they will give you this pad to sign on it. Now when you sign on that pad, the system automatically compares that signature you have signed to the existing one they have when you created the account. So what they are actually doing there is comparing what? Your handwriting. The advantage is that it is difficult to what? Imitate because of the pressure that we use to also detect. It is very difficult to imitate and widely accepted what? Socially. The limitation is writing styles changes over time and injuries may affect handwriting. And we are all aware that in general, biological biometrics are what? Behavioral biometrics are what? Dynamic. It changes gradually over time. So this shouldn't be something out of the box. Then we have signature verification. Signature verification authenticates individuals based on their signature behavior. Based on their signature behavior. Please a moment. Okay, please let's continue. Sorry for that. So signature verification authenticates individuals based on their signature behavior. We have the types of signature verification. We have the static verification, which analyzes final signature image. We have the dynamic signature verification, which analyzes your pressure, the speed, the acceleration, and then the stroke order. So these are two. One just analyzes the image that is there, and then the dynamic one takes into consideration the pressure you put on the pen to sign, the speed you use to sign, the acceleration of the signature strokes, and then the stroke what, the stroke order. Application: banking systems, legal documents, contract verification. And then we have typing speed pattern recognition, which recognizes or which allows us to identify individuals based on their typing rhythm and then keyboard behavior. Every person types differently, and it will surprise you if we actually plan an entire environment to test it out. It will surprise you that we all have different typing speed. We all have a way that we press the key. We all have time between keystrokes. We all have different ones, so we can use this to actually identify you. So we have error patterns and then typing pressure. Applications are in online examination systems, continuous authentication, and then cyber security systems. So intentionally, I will add some feeling to your mid-semester exam so that when we are done, we can come back and relate with this. Advantages is that no extra hardware is required. Continuous authentication is what is possible, and the limitation is that fatigue affects what, your typing patterns, and different keyboard affect your performance. We also have what we call the gait recognition, which identify individuals using the walking style and then body movement patterns. So walking patterns are influenced by skeletal structure, posture, muscle coordination, and then body balance. So gait recognition process, the gait recognition process is similar to the other one that we said. And remember, the other one, we require the voice recognition, we require the voice. Here we require the video, motion detection. This word, how do we even pronounce it? Who can pronounce it for us? Who can help me pronounce this word?
Silhouette.
Is that how you pronounce it?
Yes, sir.
That's how we pronounce it. Really?
Yes, silhouette.
Oh, I see. So Google is also saying it's silhouette. I see. So silhouette extraction, feature extraction, and then pattern matching. So it goes through the process that the voice recognition goes through. So basically, the process for physiological is the same process for what? Behavioral. Just that the physiological, we usually capture images, but here we are capturing voice and what? Videos and keystrokes and those things. So the process is still what? The same. Just that what we are actually capturing is what? Is different. So the applications are in airport surveillance, criminal tracking, smart cities, and then border security. Okay. Advantages: works at long distances. And then no contact recognition. Now, who has seen the video of Dumesia? Is there anyone here who has seen the video of Dumesia? Anyone?
Me.
You have seen it, right? Now, it is a town here in Ghana. They have these AI cameras which can actually track people. And these AI cameras that they have has the capabilities of gait analysis. So the video that the cameras are taking, the system is capable of analyzing how we are all walking. It is capable of doing that. That is why I'm asking who has seen the video on Dumesia. There was this presentation that they did on their surveillance system, and if you have time when you go online, check that video out. You are going to learn a lot from it. And there are YouTube channels that you can learn also some of these from. Video cameras, you can actually pull the video feed to do gait analysis on them. It's just that it is computationally intensive, so maybe your usual laptop will not be able to handle the computations, but if you have a server, you will be able to do such analysis. Okay. Limitations: clothing affects recognition and injuries alter walking style. So the limitations, it cuts across the physiological biometrics. When you have a cut on your thumb, it affects it. So here too, the obstructions are similar to that. Clothing affects your recognition. When you wear fugu in the morning, how you walk is a little bit different. When you wear suit and tie, how you walk is a little bit different. When you wear the football jersey, that one, then you behave like you have all the muscles or all the energy to move each muscle in your body. Your walking style changes. When you wear a sneaker, your walking style changes. When you wear a dress shoe, your walking style changes. So injuries and clothing affect the system's performance. And then we have what we call the lip movement recognition. Lip movement recognition identifies individuals based on lip shape and then movement patterns during speech. Lip shape and movement patterns during speech. Application is in silent authentication, noisy environment, and human-computer interactions. So we have some systems that are designed to read lips, which can actually determine whatever it is that you are saying. And it is also a little bit computationally intensive. Advantages is that useful where audio is not available and enhances multimodal systems. Limitation is that it is sensitive to lighting condition, and then facial hair may interfere. So if someone has a clean shave, the system can actually see the lip and then read. But when you have grown your beard and your mustache and it is covering everything, it affects the system's performance. And then the next one is on mouse movement recognition, which is a biometric technique that analyzes mouse usage behavior. So the features measured are cursor movement speed, click timing, movement patterns, and then scrolling behavior. All these things are analyzed when we are doing mouse movement recognition. Applications are in cybersecurity, fraud detection, and then continuous authentication. And then the new one that recently joined, the behavioral biometrics, is what we call the touchscreen behavior recognition. It identifies users based on touchscreen interaction patterns. The features include swipe speed, finger pressure, gesture patterns, and then tap duration. So this is something new that joined behavioral biometrics when we started having the touch screens. So you can actually measure your swipe speed, just like I was using the TikTok as an example. How you swipe, we can use that to determine who is actually using the device. Finger pressure, we all have a way of tapping the screen. Now, if you have realized something, old men and women, when they are using their phone, the phone will be in the left palm, then they will be using the right palm to be pointing or touching the screen. The pressure that they put on the screen is different from you using one hand to operate the device. And then we have gesture patterns. We also have tap durations. Some of us, just a very brief tap, then we are done. Some of you too will tap for some seconds to make sure that they have actually pressed on that button before they release the screen. So we can use all this to determine your behavior. Then we have applications just like smartphone security, mobile banking, and then continuous authentication. Smartphone security, we all know the pattern that we draw on the screen. For those of us who have the benefit of using the Android phones, you know what we call the pattern lock. Now that pattern that we have been drawing, and you move one dot to the other, to the other, to the other, then you have the pattern. The system is not actually using the dots to draw the pattern for you. It is a pattern that has been fixed and designed on the screen that you are using. But because you and I, we need something to know that we are drawing this particular sign. That is why the developers included that. But under normal circumstance, what you are actually drawing is not the dots that you are connecting. Okay. Please, any question on this so far? Any question on this so far?
No, sir.
All right, thank you. So let's go on to signal processing in biometrics. So we are saying we transmit everything in a form of signal. So what do we mean by the signal processing? Signal processing refers to the technique used to analyze, improve, modify, and then interpret biometric signals. Biometric systems process signals such as voice, image, motion, and then thermal signals. So all these images that we are saying, the sensors takes them as signals and then sends them to where? Storage media, or sends them to the devices for us to what? To process them. Importance of signal processing include removing noise, improving quality, enhancing accuracy, improving feature extraction, and then supporting what? Decision making. So it's because of these signals that we transmit. You know what a signal is, right? When we are talking about IT, you know we communicate to the computers through signals, the networkings. Are you aware of that?
Yes, sir.
So that's the signal that I am referring to. Now we have some types of signals in biometrics. We have audio signals, we have image signals, we have motion signals, and then we have thermal signals. We use all these to do our transmission and then pre-processing. So stages in signal processing: signal acquisition, the biometric data is captured using sensors. Signal pre-processing, so the noise and then the distortions are removed when we are actually transmitting it. And then feature extraction. Important characteristics are what? Extracted from the signal. So we don't send all the signals, we send the parts that we need, and when it gets to the other end, we also clean it as well again. Then the signals are categorized, and then decisions are made based on templates that are captured. And then we have major processing signal algorithms. The first one is the Fourier transform, which converts signal from one-time domain to frequency domain. Applications are used in voice analysis and then speech recognition. And the advantages is that frequency analysis what? Capability. The downside is poor time what? Localization. Then we also have the FFT, the fast Fourier transform, which is an efficient implementation of the Fourier transform. So it's just an advanced version of the Fourier transform. So this is real-time voice processing and audio authentication. So remember, with the voice recognition, we had two. We had the fixed phrase and we have the general one, which you can say anything. So these are the algorithms that we use to what? To send those signals. So advantages is faster computation with the, which one is this? With the fast Fourier what? Transform. And then we have the short-term Fourier transform, which analyzes frequency changes over short time intervals. So speech recognition and then voice biometrics are its what? Application. And then it also has an advantage of time frequency analysis. And then the next one is wavelet transform, which analyzes signals at multiple resolution. So fingerprint enhancement, iris recognition, and face recognition makes use of this algorithm, and it is effective for noisy signals. So we also have the male frequency spectral coefficient, the MFCC, which extracts voice features based on human hearing perception. So this is actually an algorithm that was designed based on how we as humans we hear things. So speaker recognition, and then we have voice authentication. Advantage is that it has a high recognition accuracy. The limitation is that it is very sensitive to to noise. Then we have linear predictive coding, which is the LPC, which represents speech mathematically using predictive models. So I wish you had done the machine learning to a particular point. Some of these things will not have been a little bit new to you, because when you do machine learning, you are going to talk about some of these things because they are based on machine learning principles. Then applications, we have voice compression, we have speaker verification, and the advantage is that it was efficient in signal hot representation. Then we have what we call the image processing algorithms in biometrics. We have the histogram equalization that is used to improve image contrast. So for face recognition and fingerprint enhancement. We actually had a look at one of these algorithms the last time that I was presenting it. I don't remember which algorithm that we were using, but we had a look at one. We have edge detection algorithms that detect image boundaries. So the common algorithms, we have Sobel, we have Kani, then we have Prewitt. All these are several algorithms that are already out there. Now, the good thing is, if you are aware of some of these algorithms and you want to build a biometric platform, the packages have already been written there. Just like how I was saying, in Python, we have several packages that you can use for biometric systems. So people have already written the packages. So when you know the algorithm, you can actually find a package on that algorithm, just import it, and then you use it in your code. And we all have the advantage of the AI now. So if you understand what you are doing and you understand the concept and the basics, getting things done these days is not really difficult. The difficult aspect is knowing what you need, how to put them together, and get things done. Okay. Then we have Gabor filters. This is one of the most popular one. Gabor filters. It analyzes texture and frequency patterns. Fingerprint recognition, iris recognition, and face recognition makes use of that, and it is excellent for texture analysis. Then we have algorithms that we use for feature extraction. So under feature extraction, we have the PCA. In machine learning, if you went into detail, you would have talked about this one too, the principal component analysis, which reduces biometric data dimensions while preserving important information. Applications include face recognition and then pattern recognition. Then we have the hygiene faces method. This one, there are several of them that they have combined. We have PCA. It's widely used in facial recognition through hygiene faces. Advantage includes reduced storage, faster computation, and limitation is that it is sensitive to lighting changes. So when you are actually doing biometrics and you realize the computation is too expensive, you can actually fall back on PCA and use the hygiene method so that you reduce your storage and then you get a faster computation. That is the whole point of most of these algorithms, so that we have some algorithms which reduces computation but also reduces accuracy a little bit. We have some that increases accuracy, but it is also computationally expensive. So each algorithm has its positive and then negative. Then we have what we call the linear discriminant analysis, which is the LDA, which improves separation between biometric classes. An application includes face recognition and then voice classification. The facial faces method, which uses the LDA, which is used in the facial faces recognition system. This has a better classification accuracy, unlike the previous one. Then we have the independent component analysis, which separates independent hidden features. So we use it in voice separation and then face recognition. So the advantage is that it can capture complex hidden patterns. And we have the local pattern, which is also a texture analysis algorithm used in facial recognition. So the applications obviously facial recognition, text classification, and then the advantages is fast processing and good gesture analysis. Now, whilst we are learning this, you realize that some of these algorithms are not solely meant for biometrics alone. Just like the previous one that I mentioned, it is also good for textual classification, the linear binary pattern. So I don't know the project works that some of you may be doing, but if you are doing a project work in relation to machine learning and the rest, then this particular note will be beneficial to you, because you can take a look at the notes and you find some of the algorithms here which may end up supporting your project. Anyway, then we have machine learning algorithms in biometrics. As for these ones, I'm sure you are all aware of this, the k-nearest neighbor. It is one of the most popular classification algorithms. So it classifies biometric samples using nearby data points. So face recognition and then facial verification. The advantage is that it is very simple to implement. You can write about 100 lines of Python and you will be able to implement this. The limitation is that it is slow for large data sets. So it also gives you a cue. If you are doing something and your data set is large, then it means KNN is not for you. And then we have the support vector machine, which separates classes using optimal boundaries. Fingerprint recognition and then face recognition, SVM advances there. It has a high accuracy. And then we have decision trees, which uses hierarchical decisions for classification. So we can use it for behavioral analysis and then user classification. Then we have random forest, which combines multiple decision trees. Application, multiple biometrics and then fraud detection. And the advantage is that it has a high accuracy and then it reduces what you call overfitting. Then we have the neural networks and deep learning algorithms. These are a little bit advanced version of the previous one. The ANN, which is the artificial neural network, which stimulates human brain using interconnected neurons. Applications face recognition and then voice authentication, as well as iris recognition. And then we have the convolutional neural network, which is the CNN, which is a specialized neural network for processing. So for face recognition, fingerprint recognition, and iris recognition. Advantage, automatic feature extraction and then very high accuracy. But the downside is this is also computationally intensive. Then we have recurrent neural network, RNN, which process sequential biometrics. So voice recognition, typing biometrics, and speech processing. And we have the LSTM. You also have by LSTM and the rest. So this is advanced advanced RNN for long sequential dependency. So speech recognition, behavioral access. Then we have autoencoders used for feature compression and then reconstruction. And then we have the matching algorithms when it comes to biometric. We have the Euclidean distance. As for Euclidean distance, if you have done a little bit of how do they call it, the advanced mathematics, you will get to meet this. It measures geometric similarity between feature vectors. So applications are in face recognition and then signature verification. We have Hamming distance, which measures the difference between binary. Application includes iris recognition and fingerprint matching. And then we have DTW, that is dynamic time warping, which compares signals that vary in speed or timing. And the application includes voice recognition and then signature analysis. And then my favorite one, the hidden Markov model, the HMM, which is a probabilistic model for sequential biometric data. So you use it for recognition and then gate analysis, switch recognition. So the last end of this meeting or this note is on the biometric system architecture. So every system consists of interconnected components that work together to perform, and the biometric system architecture is also the same. We have the sensor model, we have the data acquisition model, we have the pre-processing model, we have the feature extraction model, we have the template database, we have the matching model, and then we have the decision model. So when you are building a biometric system, these are the models that you should get in there. You need the first model, which is the sensor model. That's the hardware. You need a data acquisition model. You can make this a software. You need a pre-processing model. That is also a software. You need a feature extraction model. And you can build this component by component. At the end of the day, you merge them together. Then you have biometrics. So we have sensor technologies. We have optical sensors. We have taken a look at it. We have capacitive sensors. We have cameras. We have microphones. We have infrared sensors, and then we have thermal cameras. Then database management systems. I don't know if it was your class, but we discussed database, I think, on our second meeting, and in the regular group, someone missed class, and then he came later on to find out if there is a dedicated or database that has been designed for biometrics. So the answer is no. The normal databases that we use for our daily activities, the same thing that we use for what? Biometric systems. So the database management systems help us to store our templates, authentication login, user management, security control, and then fast searching. So if you check note for week 2 and 3, you get to know that there is a section on databases that we discuss which covers that aspect. Then we have types of biometric database. So the same thing that applies to the normal database also applies to biometric database. So we have centralized database, which is a single location that we store everything. We have distributed database, which is multiple servers that we distribute our storage on. Then we have the cloud database, which is an internet-based storage that we can use. So AWS, DigitalOcean, Heroku, all those ones are cloud database that you can use for your biometric system. And you can have MySQL, Postgres, and the rest. You can also use that for your biometric system. So there is no specialized database for biometrics. Just like I kept on saying about 2 weeks ago, we don't have any special database for biometrics. Our existing databases are comfortable working with biometric data. Please, is there any question? Any question, please?
No, sir.
There is no question.
No.
No question, sir.
All right. So I will share a source code with you. Then you go through. I'll give you a small exercise to do on it. After our midterm, when we meet, we will discuss that source code, and then we will take a look at what I mentioned earlier on. If someone is trying to fool a biometric system, let's say for instance a voice recognition system, and then I am trying to get into it even though I am not authorized, how would the system know that this person that is trying to, maybe I have a recording of the actual person's voice and I'm playing it to the system, how would the system be able to detect that? After our mid-semester exam, when we meet, we will discuss that and some few other things. Then we will talk about the assignment that I gave you earlier on. If you remember 2 weeks ago, I gave you an assignment on template, that is the fingerprint. Or I did the fingerprint and I told you to do the facial recognition rather. Yes. So we will discuss that and how you go about it and submit it as well. So if there is no question, I will kindly end the meeting here. I will share the recordings with you as well, and then the source code that I was talking about, I will also share that with you as well. Please, do you have any question on the mid-semester exam before I end the meeting?
So when is the missing?
So the midterm we are going to do it
Is it going
next
to be abused?
week. So I want us to learn. We are learning biometrics, so
I
I
get you.
want us to remember I said it is an online portal which has behavioral biometrics built in. So when you are writing the exam, the system can actually determine your behavior and those things. So it will be maybe about 10 of G's and then 10 filling, so that the filling aspect is going to check the keystroke dynamics and the rest, and then the how do you call it, the objectives ones, the system will be observing you. So the keystrokes for bots and the rest. So when you are done with the midterm, we will actually discuss the platform on its own, which is falling under behavioral biometrics. And one of the applications of behavioral biometrics is online assessment. So we are actually going to have a feel of it. So it will be a mix, maybe 10 of G's, 10 feeling, so that we can all have a feel of it. Any other question? Any other question?
No, sir.
Okay.
Stop.
Please come again.
Hello, sir.
Yes, please.
Hello. Yes, sir. So is that the main service next week?
Yes.
We wanted to know like the areas that
Oh,
possibly.
as for the areas, we have now done up to week 6, if my memory serves me right. Yeah, we have done up to week 6. Yes, so far we have covered up to week 6. So it will cover from week 1 to week 6.
Oh, okay.
Yes. So
So it's
it,
a
it is
theory
based
or
on the
at least
discussions that we are doing. I'm not going to
online.
bring. Please come again.
Okay, sir.
Please come again. I couldn't get to the last part.
Yes, sir. That's all I've understood. Thank you so much, sir.
Welcome. I'm not going to bring anything from week 7 ongoing. No, it is only going to cover from week 1 to week 6. That is it. So what we have been discussing, the examples and the things that we have been saying, that is what is actually going to come. Nothing else like that.